Okay, welcome everyone. I would like to advise each and every one of us to subscribe and hit the ring or bell button so that you'll be receiving each and every video uploaded on this YouTube channel. Okay, let us go straight away to where we had left. This is part 2 of chemistry, paper 3, 2007, right? Now, I had told you that this paper was divided into 3 sections, that is mole concept and enthalpy of reaction. Now we are at enthalpy of reaction. Now you realize that the first page of this was where we had left. Now, question 1, procedure B. Now, that is, you need to label 6 test tube. That is 1, 2, 3, 4, 5, and 6. Right? Take your time, label them. As you can see what I'm doing. And if it was possible, if you would be there in your lab, it would be even good for you to follow what I'm doing as you do your own work and see if my results will differ from yours. But I think it will not differ that much, right? Now fill the burette with solution M. The reason was so that the reason of filling the burette solution A is to give you correct portions, right? You'll be measuring using the burette. Now for test tube 1, you should measure 2 centimeter cube. Test tube 2, you should measure 4 centimeter cube, meaning we are incrementing by 2. Now remember, now we have 6 test tube. The last test tube will have 12 centimeter cube, right? Now see, for the second one we are using 4 centimeter cube. The third one we are using 6 centimeter cube, and the fourth one we are using 8 centimeter cube, right? Now to the sixth one. Now let us go to the second part of the procedure. Now you should make sure that you clean this burette again and pour solution C. From the burette you need to measure 4 centimeter cube of solution C into the boiling tube. Why? We want to stir this 14, sorry, we want to stir actually 4 centimeter cube. We want to stir this 14 centimeter cube with solution A in test tube 1 first. Okay, now you should measure before mixing the initial temperature. Now you mix them and stir until you arrive at the highest temperature reached, right? That is for solution 1, and for solution 1 in test tube 1, for solution A and C in test tube 1, right? Now you repeat the same for test tube 2, that is 4 centimeter cube to 12 centimeter cube of solution C. Why? For solution C we started with 14. Now we should go to 12. For solution A we started with 2, we go to 4, right? Solution A we increment, solution C we decrement, right? Now you repeat the procedure. Take your time, stir, and make sure that you measure the maximum temperature reach. Initial, maximum. For each and every volume. Now remember, I know you are asking yourself some question, why are we repeating these things? Remember, all factors are constant, but we are varying volumes, right? We are varying volumes of the two solution. Now record your results in table 2. This table number 2, we had table number 1 for titration, right? Now after this you'll be told to draw the graph. Now I'll draw the graph and you'll see what I'll do. Now our graph will have the y-axis will be change in temperature, right? Let me finish first, then you'll see what I'll be drawing. Okay. Okay, it will be change in temperature against volume of solution A specifically. Okay. Now, I don't know where you always find that, where do you normally find it difficult? Because you are just following what you are being told. Okay? And you have been provided with everything. You have been given all the apparatus, all the required reagents. Okay? Now your work is just to follow the procedure keenly, do your work. Do not panic during practicals. Remember, this is where students normally have advantages, because this paper, they will just add this paper directly to the mark you get in paper 1, paper 2 average. Now this is the table, right? Look at the table. Now plot the graph. Now you should find the change in temperature. You see the initial and final. So you say final minus initial, you get the change in temperature. Now you do graphing. You plot the graph of change in temperature against volume. That is for solution A. Look at what I am doing. Make sure that your points are visible. Okay. You will join the points using your ruler, right? Now see what I am doing. I did it a bit faster so that we can reduce the time spent watching this video. But what is important is you to understand, right? Now this you'll see my lines. I'll join my line at some point. At some point there, my lines will meet, and funny enough, these lines will meet at the point whereby our actual temperature didn't reach. Okay, now you'll see it is very important that now that is where you'll find you determine your maximum change in temperature. That is at 11.1. You have seen where the lines meets. Sometimes students take the highest point. No, where the lines meet. Okay, now from the graph, look at the volume. Now from that graph, draw a line coming down. You will get the volume. Now we shall use the volume, the moles we had gotten there, molarity. Now this will be equal to 1000. What about 6.8? Cross multiply, you will get 0.6 there. Okay, now change of heat, that will be mass times specific heat capacity times change in temperature. That is very simple. You insert the values and get the actual change of it. Okay, now the solution given. Now what else will you do? What else is that our mass was 16, right? Times specific heat capacity, that is 4.2 given, times 11.1, that is my change in temperature, that's maximum. Now is equals to 745.921, right? Now and 3.31, right? Now this, if you want the kilojoule per mole, that is the change of it. It will be what you have gotten over 1000, right? Now that's where we have reached. Thank you. We'll be uploading session 3 shortly.